So don't forget. So I just showed amazing animations and we forgot to record them. Yeah, so this is the most important one. You see how it points, and we are moving on the blue line, but there's a vector pointing at the line. How cool is that? Okay, so now you know this. One more example. This is a good quiz or exam example, which is, let's find parametric equation of the line going through a point and a point. That is also important. So let's see. Parametric equations of the line going through A to B. What is going to be your first step when you see this in your homework? Yes?
You know the initial point and you know the final point, so all you're really looking for is the vector.
Yeah.
So you can kind of like do it backwards from how we just did it.
Let's do it, yeah. Let's find A, B, exactly. The first intuition is, let's find this vector. So what is this vector? A, B. Who knows? 3 minus 2, right? 3, yes, no?
Minus 1, minus 4.
Minus 1 and minus 4, minus 5. And then 1 minus minus 3, that is 4. So all remember how to do this, don't skip homework. That's what we're gonna call directional vector. So let me write down. So let's choose first. Initial point we're gonna be using. Initial point. What they're doing in the video, they call it P sub 0, but I guess I should not confuse you, just call it A. Let's choose 2, 4, and minus 3. Then the vector, that's what they call directional vector, which is kind of tautology. That's, you know the word, right? Tautology?
No.
Tautology. What is the word in English? When vector is directional, so why would you call it directional vector if vector has direction by the definition? Direction vector. Tautology. I forgot English word. Yeah. A, B is going to be 1 minus 5 and 4. We just calculated it. Take the last point minus the initial point. Then let's build this system. So we already have AB and we have the original point. That is enough to build the idea of R equals R sub 0 plus VT, either in vector form or in parametric forms. In the parametric form, it's going to be X. So both ways, let's do both ways. So R will be R sub 0 is 2, 4, and minus 3 plus vector V is the direction. We just found it 1 minus 5 and 4 times T. So now you feel comfortable with this or not? How I just did it. That is my point A. But again, do you see why it's sometimes a point, sometimes a vector? It's a point A, but then we're pointing at that point A, and that's what builds a vector, right? Because in that animation I showed you, there's a pointer that goes towards A. And then there is a vector V, which is a direction. Make sense? Yeah.
So we're writing this one with R sub 0, AC. Is R sub 0, is that going to be a vector or a point?
So R sub 0, it's like this. That's why I'm very careful with notation. This is a vector. Yeah. This is the vector.
Okay.
Yeah. Let me write down before I answer that question.
So even though it's a point, we're denoting it as a vector.
Because there's a vector pointing at the point. Make sense? That's
Yeah.
So, and then I can always unfold it like so. 2 plus 1t. Usually people don't put 1. 4 minus 5t. Minus 3 plus 4t. Do you all know what I'm doing here?
Yeah.
I am multiplying 1 times t and adding 2. Minus 5 times t and adding 4. And then, there was a question here. Just a, any question? Okay, then you.
Can you go back to that statement you made about the coordinate? When you're talking about this, if there is a vector that is being applied to a coordinate, then you translate the coordinate into a vector? Is that what you said?
Yeah. It's here on the picture and on that animation. See? This is my original point, A. There is a vector that is pointing at A, and we're going to call it R sub 0. That is what's the complicated difference to understand. And I will write down right now the parametric equations. X, Y, and Z. And you're like, but there's a point there. So point with parentheses X, Y, and Z, but R sub 0 pointing at that point makes it a vector. Make sense? Because the whole idea is this. The whole idea that we keep pointing at things. Things are located in 3D space. A point is fixed. A line is fixed. But everything can be described using vectors, and they are moving. They keep pointing. That's kind of the complicated thinking here. And let me write down this last form, which we did with the very first one. Is parametric equation of x of t, y of t, and z of t a system. And then maybe also this explanation will help you. Again, the original point, x started from 2. Let's see. X started from 2. You can see it from many places. From this 2, from this 2, and from this 2. X started from 2, and then it moved with the speed 1 multiplied by time t. Y started with 4, and then moved with the speed minus 5 multiplied by t. Minus 3 for z, and then 4 times t. When you collect these 3, that gives you p, or that gives you p sub 0 or a. When you collect these 3, that gives you a vector v. So that's also the way to see that. All 3 notations means the same thing. 1, 2, 3. Yes.
So if we use B instead of A, would it like look the same? Exactly.
That's a good question. If they tell you to move directionally there, then you have to choose carefully from where to where you're going. But if we're describing the line, then you can choose any point. Yeah, that's a good question. So
would have been like 3 plus t, and then minus 1 minus 5t, and then 1 plus 4t.
So depends what they're asking. Find the parametric equation of the line going through. Your homework will have, I will show it actually to you if you want. Your homework will have multiple ways to explain it. And he is right. We can choose different points and even going down if we want to. So then we need to change the slope. The slope will be now a minus b. 2 minus 3, 4 minus 1, minus 3 minus 1. Then yes, you can go down and the equation of the line will still be correct. Because line is a line. Line doesn't have a direction, right? That's an interesting, confusing idea. Line doesn't have a direction. It's just pencil floating in the air. But we're using vectors to describe it. Vector either going like so or like so. Line doesn't care. It's still there. So you can use different directions and different points to describe the same thing. And your homework will ask you, are all those descriptions matching the same line? I saw a multiple choice question there. And then you'll have to choose this way describes this line. This way describes this line. This way does not describe this line. There was also this way, small one, also describes this line. So that's interesting that it can have different sizes, it can have different directions, but it should not go where, it should not go like so. So that is kind of confusing part also. That is part of your homework there. One more.
Yay.
What?
Yay.
Find the vector equation of the line going through the point, but then parallel to the line with the equation R. So let's see. How to draw this. Let's imagine. You first need to start. I don't want to show you the pictures right away because I think then you will get used to it that it's always given. You have to actually try to imagine it. So I have a line. Find the vector equations of the line going through the point. Let's draw the point minus 1, 4, and 5. This is a point in 3D. Yes. Then it is parallel to another line. And that one has a direction. So we don't know the direction of our line, but it is parallel to this line with the given direction. Direction now is a synonym of vector if you think about it. So this is R. Let me call it R. Is 2 Oh, actually, I need to ask you this question later. Yeah, so we have this one. I need to ask you, okay, let's do like this. R, what kind of numbers I should put here?
2, 0, 1.
2 what?
263.
263. Yeah, do you guys understand? To find this, only the direction matters. I need to see these T pieces, because that is the slope. These pieces, they just give me the beginning point, and I don't care about that. If I only care about the direction, I will do 2, 6, and 3. Does it make sense? Maybe put like so. It came from here. So this is my R. This is R of T. This is, let's call it S of T. So, interesting idea. If they are parallel, what is the directional vector here then?
Same thing.
Same thing. Do you understand that? It is shifted, so the original point will be different. But direction is direction. So it's also 2, 6, 3, because they are parallel. So now what do we need to build the equation? We need to have initial point. Let's choose the one we have. So solution. 1. Initial point, there's no a, so let's call it p sub 0, is minus 1, 4, and 5. That's the initial point. Then the direction vector. Direction vector. So, since the two lines are parallel, we can have the same directional vector for the second line. Because BC, S of T, parallel to R of T, then we can use R of T, will be the same for both, which is 2, 6, and 3. Do you agree on that? Think about this. So you see, R of T, that was a line given in the vector form. This is a vector form. For the second line, we don't need. They want us to build a new line S of T. So look how I'm going to match. Answer, S of T will be, R of T used to be 2 plus 2t. But now we're going to have minus 1. Plus 2t. So point changed, direction stayed. We used to have 0 plus 6t. You see, this is 0 plus 6t. Now we're going to have 4 plus 6t. Finally, we used to have 1 plus 3t. Now we're going to have 5 plus 6t. So again, this is the understanding here that the first numbers, they telling me a point, where the point started, and then the last numbers multiplied by t telling me the direction, and that is a unique line from the point towards the direction. There's no any other line like that. There's a parallel line with the same direction but different points. And they're also from one point it can be infinitely many, like a flower, 3D flower vectors, but only with one unique direction. So that's why it's a unique representation. Yes.
So last one, should it be 5 plus 3t?
Probably. Yes, you're right. 3. I mean, you are so confidently saying that probably that's the case.
Yeah.
I just see from the voice. Remember, it was like last year in Zoom. Everyone be doing something, and then the moment Jesus will unmute himself, I'm like, oh, probably I made a mistake.
Yeah.
If he would say something, it will always indicate there was a mistake in writing. Well, I always say that I'm making mistakes on purpose to make sure that you're keeping track on what I'm doing. Questions about this? What do you think? Does it make sense?
Yeah.
It's confusing because it's a lot of information, but if you do it quite a lot, you get used to it. So you need to practice before the exam to be good at it on a test, and that's why your homework is so long. It's like 25 questions.
Wait, are we gonna ever do like integration and stuff?
Yes, 3 integrals. Don't worry, we're going to get there. We're going to do 3 integrals. It will be very beautiful. It's going to be like so, and then dx. It's going to be even d theta, d phi, d psi. It will be really cool. Yeah. You asking, I will give you. Lots of stuff.
Now I'm worried.
Now, this is kind of like awkward topic about symmetrical form. When I was reading about this, I'm like, even going through PhD, I don't remember ever using symmetric form. And then it's funny in the notes, he is saying, oh, this is kind of useless. And I'm like, yeah, that's exactly what I remember. It's kind of useless. But we always learn it somehow. Even I learned it, I remember. Symmetric form was always explained. It looks like so. It's more algebra than actually something important. So generally, if the point is given with a given directional vector, like we always have, so it's your p sub 0, this is p sub 0, and this is r, we can also just solve this system. We can solve this system for t, for t, for t, like we had it over here, right? We can solve for t, and then since t equals t, we can set it equal to each other, and that's how you get those three fractions. Three fractions have information here. Point, p sub 0, p sub 0, p sub 0, divided by a, b, c, which are coming from the vector. So, you know, these are popular when you write down the, just let me see, I will just show you how the algebra is done. So, for example, find a symmetric equation of the line going through point with a given directional vector. Everything is given here, nothing to find. X is, who wants to give me right away? X and Y and Z.
W. 4.
X is what? 2t, good job. Y is?
-3 plus 2t.
Yes, amazing. Z?
-1 minus 4.
See, so you're already mastering calculus 3. How cool is that?
Not until we get to that.
Now you solve for t. That's the idea. You solve for t each, right? So for the first equation, t will be x minus 2 over 2. I'm skipping the algebra. Have fun with it at home. The second one, t is y. I mean, I did it. You have to do it too. Everyone struggled with that at some point. And the third one, t is z plus 1 over minus 4. So since it's all t, you can set it equal to each other. And that's where you get those equations called symmetric equations. X minus 2 over 2 equals y plus 3 over 2 equals z plus 1 over minus 4. So solve for t and set it equal to each other. And that's what you call symmetric equations. Pretty useless idea, to be honest. But you can see it sometimes in the literature. Yes?
You said it's useless. Is there ever been a time where you've actually used this? Is there like a real world application?
Yeah. There is one mentioned even here. When you need to find a line segment. So that's a pretty interesting application, I have to say. Oftentimes it will be useful to parameterize a segment. What do you know? What do you think segment is?
Like part of the line?
Part of the line, yeah, exactly. Part of the line. So why we always describe the whole line? What if I only need from the whole path I was walking from home to here, I only need from Wexler to here. That's a segment between 2 points instead of the whole line. So this is exactly where they're using these equations as well. But again, not always. So let's see. From A to B, remember what we're doing here. Find the parametric equations. From A to B, let's choose the point. 1. Let's choose 7 and 6, point P. P sub 0. 2. Let's find the vector that gives me the direction. That is 9 minus 7, that is 2. 10 minus 6, that is 4. Finally, the equations are right here. You know it. X is 7 plus 2t. Y is 6 plus 4t. You're already very good at this. So here they are. We're building it right away. Oh, actually, I have it here. Something is missing though. If from the whole line, I only need this piece from A to B, I just described the whole line. What is missing? That is what I crossed out from you not to see. No, it's in 2 dimensions actually. The thing is, if t is 1,000,000, I will be like over here, right? If t is minus 17, I'll be like over here. So how to make sure I'm not going outside of this segment?
Inequality?
Yes, what kind of?
Domain.
Domain, that's also a good phrase, yeah. What kind of? Something about t. Isn't t the one who tells me where to start and where to stop, right? So I should not have t a million, or else I'm going to go really way. So yes, I'm walking from here to X, and then from X to this building, and from this building to X, and then I'm going to go home at some point. But I don't need the whole thing. How do I say, even in this concrete example, I would say, you know, from 9 o'clock till 2 p.m. I am on campus. So how to make sure this timing is indicated in math?
0 is less than t is less than 1?
Exactly. There should be something about t, right? T will tell you. This is what I was hiding. T should start from 0. Let's check. When t is at 0, then we're starting at 7 and 6. That's where I started walking. And then I should tell the equation, please stop at 1. Because when t is 1, I will be at the point 9 and 10. And it's exactly what they gave us. 2 points, 7, 6, 9, and 10. Make sense?
Yeah.
That's a very important idea, I have to tell you. It's extremely important to learn to do this. This restriction is so important, or else we're describing the whole thing. And we actually need to check, not only, sometimes we're going to teach you soon how to check the direction and so on. So this is extremely important idea, how to stop what you're counting, specifically in computer science and engineering. One more thing, last thing to write down is, this is a genius idea, actually, and this is very important to understand it and be able to write down. So, now let me put this down. One more way to see it is x of t should be 1 minus t times 7 plus 9 times t. And y of t should be 1 minus t times 6 plus 10 times t. And then the same requirement for t. T should be from 0 to 1. This is easier because you did not do any additional calculations. This is how many people see it. It's the same thing we just did, but without simplification. If you multiply 7 by 1, 7 times minus t plus 9t, it would be 2t, which we had above. But here it's interesting. 1 minus t and t are used as a switch on and switch off. And it's very computer science mindset here. So when t is 0, we have minus t1, so we are walking. But when t is 1, we have minus 1 minus 1 is 0, so we are not walking. So it says walk, not walk. Walk, not walk at 1 or 0. That's also a pretty cool idea here. Let me show you the picture of the food. Because this is what these 2 lines are. They are never Lebanese, but they're not pairs.
You know what you just did at the last minute of class?
What?
Remember the meme you sent us?